Alright, let me drink water first. Okay. Let's continue. Let me open the table of content first. Okay, if I remember correctly, okay. We are in this section. I need to try fog and also wait system call. And now we are taking a look at the exec system call. Let me open this one. Right, this is the wait. And we're not really exactly using wait. Using the wait system call, but using the wait PIT here. And I'm still not sure what is the option 0 means in this case. Let me check. Okay. The one of its children terminate. Okay. If I have a process and not child process whatsoever and call the wait PIT like this function, then the process should hang there and don't continue because there can never be a state change without children, and so the process just hang there waiting for waiting for the child process to change state, which will never happen in this case. But this understanding seems to be wrong because the code below does not hang at the wait PIT function. Instead, it returns -1 for error. It is possible because there was no child process whatsoever. but as my understanding, according to the manual, goes the program. Just saying, and there is no time, so there is no status change. PID return negative 1. Oh, wait a minute. So, okay. Where is the return status? Return value, I mean. On success, return the process ID of the child whose state has changed. If W no hang was specified and one or more children specified by PID exists, but not yet changed state, then 0 is returned. On failure, negative 1 is returned. Okay. This one. On failure, negative 1 is returned. But that is there a POSIX? Okay, there is a POSIX manual. Let me check. Bit white inclusive or of 0. Oh. Bit noise inclusive or 0. Or of 0. Maybe this one. Oh, 0 no flag. Stated. Suggested here. Okay, let me check. Okay. flag. Okay, something like this. That is so long. Okay. An explanation about zero as option in rate ID. When we specify the option in that means we didn't specify flag. I'm still not sure. Bitwise inclusive or of zero. Inclusive. Yeah, what this statement means. A number of flags. Oh, wait a minute. That's what is it called? The or in here mean something like this. I think I've seen this in the open system called open, if I understand correctly, if I remember correctly. Oh, Bitwise or what? In flag. Okay, maybe that it means maybe it means continue. Maybe the statement. Okay. To how system conflict. Maybe this. Okay. Hello, Mr. Goldstein. Welcome. Hello, Luigi. Okay, how are you? I'm still okay, I think. And what are you doing today? Okay. Previously, we take a look at this function, right? With PIT system call. And I'm kind of curious about this option, like how do we, what is it called? How do we specify the option? I mean, in the example like this, right? We provide 0 as the argument. So what 0 in here means? And it looks like giving 0 means no flag, So I'm trying to, what is it called? To give an explanation in the comment what 0 in the option means, and also about the statement here. Where is it? Bit noise. This one, an or of 0. assume it is something like this. But yeah, I'm not really sure. From main page means something like to have flags in open system call. Okay, maybe something like this. And maybe the statement. Okay, let me commit this. So of course. Oh, right. Or of 0 or more. Okay. And then we continue into the section 5.3, the exec system call. A final and important piece of the process creation API is the exec system call. Okay. This system call is useful when you want to run a program that is different from the calling program. For example, calling fork. Okay. And p2.c is only useful if you want to keep running copies of the same program, alright? However, often you want to return a different program. Okay. Exec does just that. Okay. Wait, let me check the footnote. On Linux, there are 6 variants of exec. Exec-L, exec-LP, exec-LA, exec-V, exec-VP, exec-VPA. Okay, it's the main page to learn more. Let me check. Okay. Is it a light blurry, not a system call? Okay. By the way, of topic, how did you improve your English? What are some resources you could recommend? I'm trying to get better so that I can read and understand better. I usually read an article or a book in English, and if I didn't understand some word, right, I use Google Translate. This one and change to whatever language you are familiar with. So I don't really have any resource to learn English except reading a lot of material from English, I guess. I mean, that's how I learn. Yeah. I mean, we also need to, what is it called? To analyze, right? What this, for example, what this statement means. And if there is some word, let's say meaning, let's say I don't understand what meaning is, I can just look it up in the Google Translate or any translator you like and type this. This is in Bahasa Indonesia. So I usually doing that. Read an article or read a book in English and then slowly building up, what is it called? My knowledge about English. I mean, I am still learning English, so there is some word that I might not understand yet, or some statement that I'm confused. So yeah, that's how I usually learn, by reading a lot of stuff in English. And if there is some word that I don't understand, I can just look it up in the translator. What is this mean? So up until now, I'm doing the same. Oh, okay. Then yeah, I mean, it took quite a while, but that's the only thing I know. And I don't have any specific trick or something like that. I just read a lot, and slowly I'm getting better, I guess. But yeah, I mean, reading can help understanding some language, but as you might heard, I'm still struggling to pronounce the English word. And again, this is also the part of my training, right? I'm training to speak English, not only reading the English text. Okay, let's see. Yes. Okay. And then we call fog in here. Okay, fog fail, exit. Yeah, I'm still kind of curious. Did the fog fail during the parent process or the child process? Let me check. Yeah, I'm starting to become a system, what is it called? A system developer, something like that. And one of the goal is maybe I can contribute to the Linux kernel. Okay. Yeah, I'm not sure what PIT_T is. Return value on success. The PIT of the child process is returned in the parent, and 0 is returned in the child. Okay. On failure, -1 is written in the parent. Okay. No child process is created. Okay, did I give information? Of the fork? Okay, I think that's not quite right. If the process succeeds, maybe something like this, right? If the process succeeds, right? Where is it? Return value. The PIT of child process is returned in the parent, and 0 is returned in the child process. No, not that one. Okay. Done in the child process. And if the fork process fail, -1 is returned in the parent. In the parent process. Okay, maybe something like that. Channel is written in the child process. In the parent process, this needs to be okay. In the parent process, so we evaluate this in the parent process rather than in the child process, like this one. Okay. Let me commit that. Chapter 5. Explanation about negative 1 got less than 0 then value of fork. Definite and value of fork. Looks like we evaluate the condition. Evaluate the condition of is it? Let's see, less than 0 in the parent process rather than the child process. Okay, maybe something like this. Like the condition. Okay. Alright. What is it? Okay, what is needed to become a kernel developer? I'm also still learning, so one thing that we need to understand is, well, C programming language, because the Linux kernel using C, mostly using C programming language, this one, and also some Rust. If you want to, what is it called? Maybe create a kernel driver or something like that. But yeah, currently mostly using C, the Linux kernel. And let me put this in the chat in case anyone wants to take a look. Okay. Oh. Okay, this one, type new process. Okay. Okay, this is the argument from okay, oh, we declare my ax array of pointer. Interesting. So in case anyone new to C programming language, this take precedence over this. So we can write it something like this. My ax array with length 3 with the element inside of the array is pointer to char. But if we, let's say, if we do something like this, it has different meaning, you know. If I understand correctly, it means that, what is it called? We give a pointer to array with length 3. So not array of pointer, but a pointer to array with length 3 with specific length. So there is some difference there. Okay, str dot So we duplicate this one. Okay. WC p3.c input file and then null to terminate. Oh wait, do we need null as the last element? Mark end of array. Oh, maybe we will use this to evaluate in here. Let me check. Sec VP. Okay. Sec VP. This one is an array of pointer to. Oh, wait. Null terminated string that represent argument list available to the new program. Okay, null terminated string that represent the argument list available to the new program. The first argument by convention should point to the file name associated with the file being executed. The array of pointer must be terminated by a null pointer. Okay. The array of pointer itself must be terminated by a null pointer. That's why we need this null in here. Again, the index start from 0. So instead of 1, 2, 3, we have 0, 1, and 2. Okay. This shouldn't print out. So we are not executing this one. Interesting. Runs word count. I assume it is running WC command. Is anyone curious this one? The word count or something like that. Print new line word or byte counts for each file. Okay, let's try that out. p3.c p2, okay. I think I can copy this and this one, okay. And of course we are removing the comment. Alright. Instead of this one, return 42, we are using this one. Okay. My arcs 3, right? Oh, this one is first, okay. But you know what? Let's do something like this. Okay. I like to have the declaration at the top. Just a personal preference. Okay, and then we add this one. I'm not sure if we need string duplicate str2. I mean, as far as I understand, the string literal is saved in the static storage. See, memory for the new string is obtained with malloc and can be freed. So we need to free the memory allocated for this string duplicate. It didn't happen in here. You know what? Maybe we can just use string literal instead. Let's find out. Alloc0 WC, and then this one is t.c. Wait, no, not that one. Okay, and then we need to null terminate our pointer of array. Oh, sorry, our array of pointer. Okay, and then we put that in here. Exec VP, okay. Const jar file jar const, okay. Maybe we can do something like this. Alright, in case anyone new, as if I understand correctly, this means that we cannot change the pointer that we already assigned in here. So if we do this, we need to initialize instead of declare and assign. If I understand correctly. I mean, let's find out. Chapter 5, page 3, okay. Chapter 5, page 3, right. Let me copy. Oh, sorry. Let's add the warning, right? Okay, something like this, right? Assignment of read-only location. If we provide const, we cannot change the pointer inside of the array. If we remove that, okay, set but not used. Okay, but we didn't get an error, right? So to do this, we can do something like this. WC, maybe we can do something like that. Let's find out. Okay. See, it is a different warning. Okay, and then we use exec VP. Okay, file. Okay, interesting. The first argument by convention should point to the file name associated with the file being executed. The array of pointer must be terminated by a null. File name associated with the file being executed. File name. Okay, Is the file name or the file being executed? The executable file might be the binary, something like that. Okay, so exec vp my args 0 and then my args. Alright. Then the printf, this shouldn't print out. Should not be executed. Something like this. Okay, at least it compile. I'm not sure if that will work or not. But yeah, Is there any different in here? Let parent, okay. I don't think there is new stuff in this condition. Okay. It's only useful if you want to keep running copies of the same program. However, often you want to run different program. Exec does just that. In this example, the chat process call exec vp, okay, in order to run the program wc, it is the word counting program. In fact, it runs wc on the source file p3.c, thus telling us how many lines, words and bytes are found in the file. Okay, so before we execute that, let's try to execute wc program like this. What? Oh, right. I forgot. Okay, something like this. This is the output of wc program with the source code input, right? And yeah, I'm kind of curious. Do we execute this program in the current directory or in the current directory of the program or the current directory where we execute the program? Well, let's find out. I mean, we will get an error if the file does not exist, right? Alright. No such file or directory. So we are executing in the current directory where we start the program, something like that. So if it changes, wait a minute, if we change the directory, right, should be fine. See, instead of no such file or directory, we got this one. Yeah, except the path, right? So that is interesting. Oh, wait a minute. Okay. Can we like what is it called? Yes, okay. Can we like maybe use the macro file, to get the path of the file, and we can check like this chapter p3.c, passing that to the pager less, and then where is it? Okay, right. We are passing the actual path of the file instead of just hardcode that. Okay. Now let's try compiling again. The latest C++ version. Probably good stuff. Wait, did CPP that you mean C++ or the C++? I mean the CPP program that I use is the C preprocessor, not the C++. Some people might get confused. Yeah, the C preprocessor. I usually use this to check if the macro expand correctly or not, For example, this file, right? What is it called? This is a macro, and if we check something like this, we can see that the macro, right? See, cons my args, WC, and then this one is actually this macro, the file macro, and it expands to have this path, chapter 5 p3.c. So I usually use the CPP or C preprocessor program to check if the macro expand correctly. Not the C++. A macro is like a pointer. No, a macro is not a pointer. To make things easier to understand, a macro is like we are just replacing the macro with whatever it is in the macro. Where is it? Maybe I can find an example. For example, something like this, right? We define a macro called limit, and when we compile or in the preprocessor or in the preprocessing process, we will replace this with the value of the macro. In this case, we replace it with 5. So this will become 5 instead of limit. So it is like what is it called? An alias maybe, something like that, or a shortcut. And if we, let's say, change this to 69, it will replace to 69. I think I also have an example in this one. Macro playground, like, okay, I have macro called live and also called nice, right? And then during pre-processing, this macro nice and live will be replaced by, what is it called? By the equivalent. Well, we can try running that. Playground macro, this one, something like this. We replace nice with 69, and then we replace the macro live, which contains nice, right? And we can also open this in here, I guess. Macro playground. See, this is the macro live, right? And what is live? Nice negative 42. And what is nice? Nice is 69. So it becomes 69 negative 27, sorry, not 42, 27. And if we run this, macro playground become 42. Oh. Yeah, something like that. Wait, hold on. I didn't provide any print statement, so how did we print out the value? Yeah, looks like I didn't have the new, what is it, the new binary. Let me recompile this. Right, it should not print anything out. But yeah, that's what I understand about a macro. It's just an alias or a shortcut for some, what is it called? For some other instruction, maybe something like that. So that is why, I mean, well, if you take a look at this, right, I have a macro for max speed and overflow value and even the error message to make it consistent, right? It's just replacing the macro with whatever it is that we provide. There is some, what is it called? Operation, I guess, like this one, which concate into the name. So if you provide the name and you set something, it will become unused something. This is what the operation, this operation means. Okay, and then, oh right, of course, don't forget about this one too. Attribute unused. So if you use the macro like this, it will become something like this. We are just replacing the value with another value, something like that. Okay, is it like a variable? It is like a variable, but it doesn't create a space in memory. It just changed during compilation. Yes, it just changed during the compilation. So it doesn't have a memory space, something like that. I mean, if you know about, what is it called? About cell alias, maybe it is something like that. We get an alias for the value and then we can replace those alias with the actual value. So maybe, well, to make things easier to understand, you can think of it like what is it, compilation variable rather than a runtime variable. But yeah, it basically just replacing the value during compilation. That's why I check the macro value with this, the C preprocessor, to check if the, what is it called, if the value of the macro correct, you know. Okay, now let's try, did I already compile that? No, let's compile again. Chapter 5, okay. See, we get the right path. But yeah, this is not really the absolute path. So if we move the binary somewhere else, we might get this error. No source file or directory. Okay, keep that in mind. Put the file macro. Okay. Calling fork, then wait, and then exec. Okay, in this example, the chat process called execvp, okay, and WC program. It is the word counting program, right? See on the source file, just telling us how many lines, word, and bytes are found in the file. Okay. The fork system code is strange. Its partner in crime. Its partner in crime exec is not so normal either. So it's not so normal either. So fork and exec is not normal. Okay. What it does, given the name of an executable, the example WC. Okay, so the first argument, right, is the executable file. In this case, is WC program or executable and some argument, right? p3.c. Okay, it loads code and static data Oh, it loads code and static data from that executable and overrides its current code segment and current static data with it. The heap and stack and other parts of the memory space of the program are reinitialized. Then the operating system simply runs that program, passing in any argument as the argv of that argument vector of that process, or maybe argument value. I'm not sure what argv in here stands for. Some people call it argument vector, some people call it argument value. So yeah, I'm not sure the official term for this argv. Thus, it does not create a new process, rather it transforms the currently running process, the currently running program, formerly P3, into a different running program. You see, after the exec in the child, it's almost as if pc.c never ran. A successful call to exec never returns. Wait a minute. Oh. Okay, let me add an explanation. So is it like what it means? When we are using exec, do we copy the binary? I mean, what loads in here means from that executable and override its current code segment and current static data with it. Hello. Chris Spooky, welcome. We are currently learning from this book, Operating System 3 Easy Pieces, and we are in this section trying out the exact system call, and yeah, we are trying to understand what the exact call does from the explanation. Oh yeah, the reference is in the description if you want to check that out, or maybe I can just put this in the chat. It loads code in static data. Okay. Did you finish making lips? Well, I'm not finishing until the end of the book because I want to moving on into this book. So did I finish making lip? I'm done with that, but I'm not finishing the book. I mean, you can take a look. Yeah. I mean, you can take a look at the repo if you want. Where is it called? Scripts. You can take a look at this repo if you want. I mean, there is some new change that I do. For example, like this one. Am I liking? Wow, it is so slow. Yeah, I'm using union instead of numbers symbol in the error. I'm also planning to use goto, to try out the cleanups mechanism. Yeah, it's slow. I mean, if you take a look at the Linux kernel coding style, okay, it took a while. Go to this one. I'm planning to try this out off stream. Let me put this in the chat. Basically, like creating some kind of centralized return to free, what is it called? To free the resource, right? So maybe I will add this in the repo later on. But yeah, for the live stream, I'm moving out into another book, but I'm still sometimes taking a look at this one. I'm not adding a feature. I mean, I think this one. This project purpose is to learn C, programming language, rather than creating a full-fledged Lisp interpreter. So the feature implemented in this project is only a small subset of what other Lisp interpreters have. So yeah, the point is to learn C programming language. So I want to focus on the C mechanism or something like that. I was studying code statement in C++ earlier. Oh, okay. Right, I mean, it looks like a nice way to, what is it called? To centralize exit a function, For example, we don't really need to remember to free some resource, right? And we didn't create another call stack, another frame. We didn't create another frame stack, something like that. I forgot what it is called. Yeah, anyway, but we didn't need to call a function which add a new stack in the call stack list, I guess. In the call stack memory, maybe something like that. So yeah, I want to try this out off stream. But for the live stream, we are moving on into this book, The Operating System 3 ECPs. But it is considered practice using it in C++. Right. Considered bad practice. Okay. In C++, I don't know the case in C. Yeah, I mean, some people call it bad practice. But again, it depends on how you use it. Again, the Linux kernel using the goto function, the goto statement, right? So in some cases it can be useful, but in other cases it can be bad, depending how we use it. I think someone wrote an article about that. Bad practice. Let's take a look. A valid answer to don't do it because it is best practice would probably be considered as not an answer or something. Yeah, I mean, people still discussing this quite early, 2021, right? In the 2021, people still discussing this. So it is still a debate whether using Goto is bad or good. Again, depending on the use case. Strict Chinese common. Okay. What's doing? I'm tapping it up. Making religion out of it, as if the conceptual problem of programming could be solved by a single trait. Right. By a simple form of coding discipline. And again, it depends on the context, So we need to understand why is it bad and why is it good. Let me copy this in the chat in case anyone wants to take a look. The use case you said. Okay. Yeah, anyway, let me continue reading things. Getting it right. Ramson's law. As Ramson stated in his well-regarded Hints for Computer System Design. Okay. Get it right. Neither abstraction nor simplicity is a substitute for getting it right. Neither abstraction nor simplicity is a substitute for getting it right. Sometimes you just have to do the right thing, and when you do, it is way better than the alternative. There are lots of ways to design API for process creation. However, the combination of fork and except are simple and immensely powerful. Here, the Unix designer simply got it right. And because Ramson so often got it right, we named the law in this honor. Okay. got it right. Okay. Yeah, I'm still not sure how to exec function testing. It loads code and static data from that executable and overwrites its current code segment. What it means overwrite its current code segment and current static data. With it, is the current code segment in here? The executable that we provide, in this case WC, or something else. The heap and stack and other part of the memory space are the heap and stack and other part of the memory space of the program are reinitialized. Then the operating system simply runs that program. Thus it does not create a new process. Rather, it transforms the currently running program, formerly P3, into a different running program, WC. That to exec in the chat, it is almost as if P3.c never ran. So, from what I understand, we are replacing the child process, right? After the fork here, we are replacing the child process that should run this instruction with another program. Is that it? I mean, maybe if we do something like this, we fork a process and then we use exec function directly. Let's find out. Okay, right. I forgot to get this out too. Okay. Oh, interesting. Okay. Looks like we are replacing the process with another executable process. We are replacing the running program in one process with another program rather than create a new process. See, it does not create new process. Okay, interesting. When we use exec, replacing the program in the current process
Okay.
The program in the current process with another program. With another program. So we are not creating new process. We are reusing, maybe that's the word, the current process with different instruction. Maybe that's the word. We are not creating a new process. A new process. So we are not creating a new process, but we are using the current process with different instruction. That's why the next statement is not executed after exec is not executed. Different instruction. Maybe reusing is the word for the exact function. I mean, as far as I understand from the explanation, right? It loads code and static data from that executable and override its current code segment. So I'm assuming current code segment in here is the current code segment of the p3.c. This one, p3.c. We are replacing the instruction in the p3.c with the instruction from wc. If I understand correctly. After the exec in the child, it is almost as if p3.c never ran. A successful call to exec never returned. I mean, it returned integer value. Let's check the return value. Return only if an error has occurred. The return value is -1. Negative error. Okay. Maybe we can do something like this. If error equal -1, I think you can use p-error, pin system error message. Error, no, okay. Something like this. Let's try to compile, okay. Alright. The operating system simply. Placing the program in the current process with another program. In this case, replacing that process from fork with DW program. That process from fork with W program. Okay. We are not creating a new process, but we are reusing the current process with different instruction. Our statement is not executed. Only return when fail. Okay. Okay, maybe something like this. After the exec in the child, it is almost as if pt.c never run. A successful call to exec never returns. Okay. Well, except when it fails. And that is kind of interesting, you know. I mean, if we provide the, what is it called? The unexisting file, right? The return value is still not -1, even though we have an error from the program, right? It's like we are doing this. See, no file or directory, right? So maybe the error is when the executable does not exist. Does not exist. Again, there is no command called ino. So let's try this out. Exec error, no such file. Okay. So exec will only return a value when the executable does not exist. Or maybe there is another condition too. But one condition that we know is that what is it called? Exec only return a value when an error occur. Say VP, okay. The value when an error occurs, such as when the executable does not exist. Okay, let me commit this. Chapter 5. Example. Wait a minute, let me check. Of using exec system call. Looks like exec did not create new process like fork, thus, but rather replacing the current process instruction with another executable instruction. Currently still not sure if that is correct. Need more info. And I'm not sure if that is correct. Oh, we already have that in the standard I/O. Okay. I'm taking a look at this. I thought that we will get an error when compiling with this the error function, but it turns out we are not. I'm still not sure if that explanation maybe doesn't work. Okay, karena nation is correct. Okay. Need more info. Okay. here. But AI should be fine. 72 character, okay. Alright. It does not create a new process. It transfers to current neuron. Okay. Why motivating the API? Okay, so I think I will take a look at this on the next session. So that's it for now. Thank you for watching and see you next time. Bye bye.